now. All right, so this edition of the Guild Meetup is sponsored by ExcelQ, which is a simple to use, powerful AI driven testing platform. It's one of the few or only cloud based continuous testing platforms I'm aware of that seamlessly integrates both API and web testing without writing a single line of code. It also integrates with your manual testing process, so it makes it possible for the whole team to manage your QA lifecycle effectively. Typically, I heard that they save their customers 70% off the costs involved in basically the changing and the maintenance of your testing efforts. So definitely check them out. Support the Meetup. If you're in the Meetup room right now, click on the Support the Meetup button. All it's going to do is send you to the main page, to send you more info about them, and they let you know. It lets them know that, hey, you found out about them from the Meetup. If you're on YouTube, there should be actually a comment. In that comment, there's a link there also. So just click that link and show some love there. That'd be awesome. So for those of you that don't know, Anton is the CTO and co-founder of Automate the Planet and inventor of Bellatrix test automation framework. He has over 10 years of experience in the field of automation testing. He designs and writes scalable automation solutions and tools. He consults and trains companies regarding automation testing and all the efforts around it. And really, he really is passionate about automation. One of the few people that also knows really C# really well, and I think C# is a really cool language I think a lot of people overlook. And as I mentioned, he is the co-founder. He blogs frequently at Automate the Planet. If you haven't seen it yet, check that out as well. So Anton, I'm bringing you in now, and let's get into it. Hey Anton,
Okay,
welcome
thank
to
you,
the
John.
Guild. Yeah, it's all yours.
Thank you. Thank you. Okay, let's begin. I will basically present some of the stuff from, my book about design patterns. You can check it on Amazon. Basically, you introduced me already, so I will fastly show you a few design patterns. Can you just tell me how much time do we have for the demos?
Yeah, so you could spend 20 to 30 minutes on the demo, and we'll take like 20 minutes Q&A to 30 minutes Q&A, depending how chatty everyone is. So it's up to you. You could do a longer demo, shorter Q&A, or shorter demo, more Q&A. So it all depends.
Yeah, okay. I can talk for hours. So,
Perfect.
yeah, so I will just briefly introduce a few patterns. So what are the reasons for test failures usually? Of course, the best way is to have a real problem in the system. Many times there is a problem in the test environment. Other times there is a problem in the test itself, the so-called flaky test. Then there is another issue called test-on-test dependency. We usually, want our test to be independent from each other. Other common problem is when we use hard-coded test data, and of course, if we use a lot of code duplication, this leads to a lot of problems in the tests. So these are common reasons for test failures. Right now, I will just briefly explain a few, directly show you a few demos. For example, imagine I created these sites for the book itself. This is like an online shopping cart where we can purchase rockets. It's using asynchronous technologies such as Ajax. So basically, as you can see, it's this spinner. It's not reloading the whole page. I can add this to my shopping cart. I can increase the quantity. Again, as you can see, everything is asynchronous. I can apply a discount. And then I can proceed to checkout, fill all of the data, and complete the purchase. This is our test. I will show you 3 versions of it. The first version is like how we shouldn't do it. Here I created 3 tests. Here I use, of course, Selenium WebDriver in C#. This is an MS test project. Before all of the tests, I just start the browser. Then after these 3 tests, I close the browser. Then we have 3 scenarios. The first one is when I create a purchase with a new user. Basically, what I do here, it's like I'm a junior developer, so I put everything inside this single test. I navigate to the website. I find here the element that I click it. And in order to handle this asynchronous stuff, as you can notice here, I use hard-coded pauses, this thread sleep, on many places where there is this spinner. This is my current way to solve this problem. And sometimes this will work just fine. Sometimes it won't, because, sometimes this element will show up before these 2 seconds. Sometimes the test will need more, and then the test, maybe it will fail. If the element is appeared faster, then this means that we lose this, for example, 1 second for each particular action. And as you can see, there are a lot of pauses here, maybe 20 seconds for each test, which is a bad thing. Basically, here I'm doing the actions that I showed you during the example. And also another bad practice is that I coupled the 2 tests, which is not good. I depend and I expect that this will be the first test that will be executed, and it will create the user when I check this button, create an account. And then I expect in this second test that the first purchase is successful, so that my account is there. And when I preview this data here, up here during the login, the information will be previewed for the second purchase. But as you can imagine, this is a bad practice, because if the first test fails, then the second will fail as well. So one way to solve this problem, if I back to my presentation, is to use this basically helper methods, to use this I think it's called fluent wait in Java. Here it's called WebDriver wait. Basically, it's called explicit wait, where I will wait until my element appears. This is the simplest ways to remove all of the pauses. And this is the thing that I do here in version 2. Basically, I just created these 2 helper methods here. Even I have one more for waiting for the elements to be clickable, because sometimes even the element is there, Selenium is throwing an exception, an error. So I removed all of the pauses. As you can see here, there are no hard-coded pauses anymore. Instead of the native driver find and wait, I use my helper function, wait and find element. Not the best name. Still, this test is not so maintainable, because it's basically copy-pasted of all of the elements. This is why I want to show you one cool design pattern. It's called Decorator design pattern. It's basically, it will help us to do 2 things. It will help us to extend our code without changing the core, but basically we'll follow the solid principles, where we will basically, once we wrote the engine, we'll be able to extend it, but without modifying the existing code, because usually this leads to regression, even in tests. And we do this through these decorator classes. Basically, we create wrappers around the driver itself and the native elements. These are the 2, component and concrete components. And then through the decorators, we can add new behavior to the existing methods. For example, we can add existing another logic when we perform a click of a button. Then we can add another decorator, like another wrapper around our wrapper that we have already, to add a new functionality. For example, if you click a button, you want to print on the console what is the locator for the element, for example, or I don't know. And I think you'll get better the design pattern when I showed you the demo. Basically, first we need to define an abstract class or an interface for the component, as you can see on the diagram here. This is an abstract class or an interface, the component that will wrap. And here we defined all of the actions. The another benefit of the this design pattern is that we can change a little bit the API, meaning that we can make it a little bit prettier. For example, here I added a new method called start. As you will see in a minute, here we use another design pattern called factory method design pattern, where basically we will start the browser based on this enumeration here, which is basically the type of the browser. And as you can see, I removed some of the methods part of the native WebDriver and simplified it a little bit. If we look into the concrete implementation of this component, this is from the diagram, this concrete component here, we basically implement this abstract class. As you can see here, we derive from the abstract class and we need to implement all of the methods. This is our, as I said, factory method, where I have a switch statement through this enumeration where I initialize the browser. And I create this explicit wait here that I will later use in the other methods. Also, I use the WebDriver and WebDriver wait through composition. The composition is like another programming technique where basically I'm getting the driver and the WebDriver wait through variables instead of just getting them from the base class. And what else? Basically, in all of these methods here, I'm calling the native WebDriver. This is iWebDriver that I already initialized. The whole magic is happening inside this find element and find elements methods, where basically first I'm waiting for the element to appear. Here I'm passing the the native locator, the by locator of WebDriver. So through the WebDriver explicit wait, I'm waiting for the element to appear, and then I will talk in a bit about this. But basically, we are creating this native the component for the web element, the wrapper, that I will show you in a minute, and then we create it. Yeah.
Just a quick question. Someone had a question in YouTube. They want to know: is there a max wait time for the method WebDriver wait?
Yeah, there is. I think here in the start, I set it to 30 seconds. Okay. But you can usually, use a configuration file or anything to set it. For example, in Bellatrix, our open source framework, we have a configuration file here, like a JSON, where basically in these timeout settings, we configure all of this WebDriver waits for the different types of actions. For example, for the element to exist, here is 30 seconds for the debug configuration, but if you want to run it, for example, in release, you can increase it, and that's fine, depending on the environment where you run your tests. So yeah, okay. So this is the concrete implementation for the WebDriver. We have a similar thing for the element itself. This is the abstract class or the abstract component. And the thing that I added here, I added a few things. First, as you know, the native element of WebDriver doesn't know how it was located. And this is something that I wanted to add to my API. This is why I added a new public property. For those of you who are not familiar what property is, this is basically similar to getters and setters in Java. This is like a syntax sugar. Behind the scenes, basically the compiler is generating these methods for us. So this is like a getter where I can get how my element was located. Then another thing that I improved, instead of having this send keys method, I wanted to have a more readable method. This is why I created type text. you know, there is a reason why it's called send keys, because you can send keystrokes from the keyboard. But right now for my API, I want only to be able to type text in the fields. This is why I changed the API. So I added these two things. And right now, here's my concrete component. The same way as I did for the concrete component for WebDriver, I'm passing this through the constructor here, and I'm using composition through variables. And I'm implementing basically all of the, as you can notice here through the constructor, I'm passing also how the element was located. This is happening inside this implementation here of the find. As you can see here, I am initializing with new. I'm passing the WebDriver, the native element that was returned and waited, and then I'm passing the locator itself. So I know, and here basically I'm just returning what I passed here through the constructor. And everywhere, basically I'm wrapping the native element. When I call the text property, I'm returning the text property of the web element, whether it's enabled, displayed, etc. Some of the magic is happening inside this type text method where, as you can see, I'm wrapping these two actions. First, the clear, which will clear the field from existing text if there is in the field. And then I'm using this send keys. And I'm doing one more thing. For the click, I'm proving it. I already know how my element was located through the by. And then in this wait to be clickable, I'm using again a new instance of this explicit wait, where I'm using this element to be clickable from the expected conditions. And this method will basically wait until my element is ready to be clicked, and then I will click it. Because as I said, sometimes your test may fail because of it. All of these methods here, they're coming from this NuGet package called .NET Selenium Extras Wait Helpers. It's official NuGet package. I think one of the core maintainers of the Selenium project is behind it. So how until now we only looked into how we haven't talked yet about the decorators and what is the purpose. As I said again, we want to be able, once we created this core logic here, because it's a lot of an abstraction, we want to be able to extend it even further when we have new requirements. Imagine that we want to add and print something to the console or to a file when something is ready. For example, something similar we do here in Beatrix. I'll just give you a quick example. For example, we have this BDD logging. The BDD logging is something like, just let me find an example here. Here it is, behavior-driven. When you execute all of the actions, the framework will do this kind of a, it will print somewhere to a file or to the console, or when you execute in Jenkins or Azure DevOps, it will print this and you know what was typed exactly and what happened with what locator it was found. And this is useful when you want to show off what happened and to see and to debug it and so on. So we want to be able to create this kind of thing in our framework or library. And this is why, if you look back into the diagram, we need this base decorator class. And again, we have these concrete decorators. Let's see in action this. Let's see first, this is the base class for all driver decorators that will basically extend the driver itself. As you can see, it implements the same, it extends the same base class that my concrete component, concrete driver implemented it. And then the other thing is that we extended it, but also we use it as a variable and we paste it here. This is how we achieve this nesting of decorators that you will see in a minute. And basically, we need to implement and override all of these methods from our abstract class. Basically, we're just calling the, again, through composition, the nested component here. We're just calling the same methods. And when we want to add a new logic, this is our logging decorator. As you can see here, right now, this is the new logic that we add. Here we extend the driver decorator, the class that I showed you before. And here again, we have the same constructor where we pass the base class. But basically this time we add the new logic. Here's our new logic where basically we're printing something to the console, and then we call the logic from the driver that we passed here. And this is and we can repeat that over and over again and add new logic on top of the new logic and so on. Basically, we're doing this inside here for the element itself. This log element is basically a decorator for the web element component. If you look at it, as you will see, we have the same class, base class for the element decorator. I'm passing here the base element, and basically I'm doing the same thing for the text. I'm overriding the same methods. Here I add the new logic, the printing to the console, and then I'm returning the text. I do the same for clicking. I add the new logic, then I click. And I can repeat that over and over again. But basically, I'm just initializing first the component, and then I'm nesting it into the decorator itself. If I had one more decorator, I was going to do the same thing. I was just going to paste that, and then this is how I add the new logic. But if I didn't have the decorators, then I was going to just go to the web element and write the code here. Then when I have something new, then I will have to do it again. But again, this is not a good practice, because if I do that, I will cause a regression probably in many tests, and I will have to test this code again and again. And if we look into the tests right now, you will see that this is the place where we here initialize the driver. Basically, I'm creating the decorator here, and I'm nesting inside it the concrete component, the concrete implementation of the web driver here. Then I use my factory method design pattern to initialize the Chrome browser. I'm basically calling the quit, or I will close the browser after all tests. And then if we look into the implementation, you will notice that right now, the test didn't change pretty much compared to version 1. We don't have the hard-coded pauses, but right now we use again driver and find element. We don't have these helper methods like wait and find. But if we like hover, you will see that here we return our abstract element, our decorator. And basically here, when I call this method, first I will wait for the element, then I will create the decorator around it. When I click, I will first wait for the element to appear, then to be clickable, then I will print to the console that I'm clicking to the element, and then I will click it. And as you can see, we changed also the API. So right now, instead of having this clear and then send keys, we have only type text. This is how we improved a little bit even the readability of the tests. I hope that this makes sense. I know maybe it's a little bit hard. Another way we can improve the tests in this kind of a context where we have asynchronous requests is to use JavaScript. Basically, as I said, my website is using jQuery, and this is why, as you know, in WebDriver we can execute JavaScript. Again, here I'm using this explicit wait, WebDriver wait, fluent wait, to basically execute this script where I will wait until all jQuery requests are done, and then I will proceed with everything I'm doing, you know. This is another way you can improve the stability of your tests. What else? I will skip this pattern because it's you know, too hard. We don't have the time. I want to show you a few other things. For example, you are all familiar with page objects, so I want to speak about page object sections. This is something more interesting. You know, the page object is something where basically you have a class where you have all of the actions that you can perform on the page, maybe assertions, all of the locators. And this is good because you can, you know, fix all of the, for example, if the locator is changed, you can change it in a single place. You can reuse the actions and the assertions, which is cool. I will just give you a short example here from the Bellatrix. Right now, right here, for the C#, I use here, in our framework, we use special page objects. I don't think that this is possible in Java, but basically we have 3 separate files for the different things that you have basically in the page objects. First, we have one file called .elements, where we have all elements that can be located on the page. They're publicly exposed. And here I found them through locators. This is marked as partial class. We have this in C#. Basically, these 3 files are the same class, as you can see, card page. But basically, it's partial class, meaning that when I build the project, this will be a single, these 3 files will be merged into a single object. That's it. But for me, it's much easier to navigate here in the folder structure. In these methods, I have only the actions that I can perform on the page. In the assertions file, I have only the assertions that I can do on the page, where I can reuse, for example, the exception messages. And yeah, basically, this is the page objects that we use. But what are the page objects, the page object sections? Page object sections are, imagine that as in our website right here, this menu, it's showed on all of the pages basically. And I don't want this, you know, items here. If I want to be able to, you know, click on them in every single page, the dumbest way that I can do it is just to copy paste the locators. By the way, you can download all of the source code for the book from here. Automate the Planet, Design Patterns for High Quality Automated Tests C#. For all of the chapters of the book, I did a lot of examples. Basically here, this table as the demo are the examples from, I think, chapter 2. Right now, I will show you some examples from chapter 4 about the readability. You can download it, it's free and open source. And I want to show you what these sections are. Basically, they help us to, basically your, you know, the sections are mini page objects. This is how you can, you know, think of them. Through the book, I basically explained like 10 versions of page objects. And I already showed you version 1. Right now, I will show you like the version with the page sections. These page sections, as I said, for example, we have one page section for this icon here and the search bar. We have another for these 2 here, because they're, for example, they don't appear on all pages. We have one more for the menu item. Sometimes we have one for the breadcrumb and for the footer. And this is how I created them. I call them not pages, but basically sections. Here is the breadcrumb section, for example. As you can see here, I nested the driver. Here we use the same decorator design pattern. So one more thing, it's up to you whether you want to expose the elements publicly or not. As you can see here, I'm using them here as private variables. Sometimes you may expose them publicly. It's up to you. Here I just created a wrapper public method called open breadcrumb item, where I just mention basically the name of the item itself, and I found it through the link. I have the same thing for the cart info section. The cart info section is this thing here. I have the two elements, the cart icon and the amount, and I have two methods for them, and that's fine. And basically we have all four sections that I showed you. And how we use them, here is my cart page. This is the cart page is this page here, where I exposed a few actions, for example, increasing the quantity, proceed to checkout, applying the coupon, and so on. As you can see again, here all of my elements are private. I'm using again through composition the driver itself. And in the constructor, I'm initializing all of the sections, and I'm using them through composition, not from base classes. And this allows me to have the flexibility, for example, in this particular page to have all four, but in the main page, as you can see, I have only three. So we have this flexibility to change the count and maybe initialize just the right ones, which is really great. And let's see. Here it's an example of how we use them. Basically, I expose the section itself publicly, so we can. This is like we exposed like a property, or in Java you have just a getter for the section itself, and then we just perform the actions that are part of the section. This is it. I think this is a really cool design pattern. One more pattern. I think we have a little bit more time. I will show you one more pattern as part of the page objects. It's called template method design pattern. It's really useful when you want to, here, let me check. This was part of test maintainability and reusability. We need to open this particular solution. Basically, this is really helpful, this template design pattern for pages that we navigate to and we wait. And for example, if you have, what is the problem? Sometimes when you navigate to a page and you directly try to, for example, imagine that we haven't implemented the decorator design pattern and we don't use every time the explicit wait. A rookie mistake is directly to try to do something on the page, and many times WebDriver will try immediately to do something and it will tell you, come on, the element is not there because the page is still asynchronously loading, and it will fail. This is why another good practice when you navigate to a certain page is to wait for particular element that you are sure that it's it's there. For example, for this particular page, we can wait for this applied coupon button to appear, and then we are sure that the page is loaded. And I will show you right now in this maintainability here solution. I created two base pages, basically base classes for my pages. I created abstract classes. One, it's called eShop page abstract class. And this is basically the base class for all pages that I cannot navigate directly to them. Imagine, for example, the billing page. I can just go there if I click through the proceed to checkout. So we have some pages part of the workflow that I cannot go directly. This is why I will extend this eShop. As you can see, we don't have this navigate method here as part of the eShop page. However, for the pages that I can go directly to them, for example, the main page here, the home, I can navigate to them through the URL. That's fine. For these pages, I created another base class called, it's again abstract class, because I don't want to be able to create instances of it directly. It extends the eShop page, which in order to get all of the sections, etc. And it adds a few things. First, we have this abstract property or a getter for the URL where we want to set, the proper URL. For example, this one here. Then we have this public open method where basically we call driver go to this particular URL, and then we have, if we return here to the presentation, we have the template method design pattern. What is it? First, we have the abstract class where we define a specific operation. And this is like you saw, the navigation method, where it's not an abstract, it's not a method for that we need to override. The only abstract method here that we need to implement in the concrete classes is this template method. In our case, this is this particular wait for page to load method. As you can see here, this is a normal method, open, and this logic here, it will be different for all of the child classes. Here in this wait for page load, we'll wait for on every page for different element to appear. This is what we want. If I click here to the references, as you will see, both of my pages, the cart page and the main page, extend this navigatable eShop page class. And here we override the URL itself. Here we set the cart, and here we set another URL. And as you can see, the difference here is that this protected method, we cannot access it outside because it's protected. Here, basically, we use this new wait to exist method, part of our decorator, and we wait for this coupon code text field that I showed you for the cart page. We want, basically, when you call the open method, you will navigate to the page, then this overridden method will be called. We will wait for the coupon page for the cart. Then for the main, when you navigate to to the original demos Bellatrix solutions, here, as you can see, we wait for this add to cart Falcon 9 to exist. This is another button. And this will be called after we navigate to the page. Then this will be called, and then we can perform certain actions. If we look, as you can see here, also I wanted to just show you actually what this wait. This is a new method that I added here. As you can see, it's a new method part of this abstract element concrete component. If we navigate to how it was implemented, as you see, we use again here the WebDriver or the fluent wait to wait for the element to exist. And if we see here, basically when I call here, please open the page. If I navigate to this method, basically we navigate to the URL and then we wait for the particular element that we want to appear, and then we'll do the action. Do we have more time, or you want to answer some questions?
Yeah, I think we have more time. Just a few questions coming in really quick. First one's from Amy. They want to know, sometimes we get a spinner or overlay after the button or an element is present. How do you handle those scenarios? I know you're saying you're looking for something to load, but what about if it still has a spinner or something going on?
You mean like the spinner, like this one?
Yes. Yep.
It really depends on the technology. As I said, I think I showed you already this. If it's Ajax or jQuery, you can execute JavaScript like this. This JavaScript, this will basically, this is inside it. If you look through the reflection code, it's basically a do while that will execute continuously this for many times, and we wait until all of the requests finish. Basically, this spinner is just some random JavaScript. But this is in the case when this is Ajax. If it's, for example, Angular, then for Angular, in order to handle this, I will show you something from Bellatrix. Again, this is completely open source and free. You can download it. For our web version, in order to handle Angular, basically I used a project called Protractor C# or Protractor.net. I'm not sure. But basically the thing that we do is that, just let me, here it is. As you know, Protractor is like, I think it was created from Google, and it's basically a test library similar to, to WebDriver for testing Angular. I copied some of the, their JavaScript because they have different locators and stuff. And again, you can use all of this in C# or in Java, whatever. You can execute it through the JavaScript executor. And this is basically how we handle Angular in Bellatrix or in any basically WebDriver test. That's fine. Here it is. Here I created the different locators for Angular bindings, models, and we have this wait for Angular method. If we navigate to it, as you will see, basically I'm executing JavaScript code again. It's just Angular stuff. And basically we can do this for all kinds of different JavaScript-like technologies to wait for these elements.
Nice. She also said it acts differently sometimes in Chrome compared to Safari. I don't know if it's the same type of deal. Browsers handle it differently depending on what technology they're using on the back end.
I haven't noticed that because, okay. For Bellatrix, right here, in order to test everything that it's working, we have something like 5,000 different tests, and for each particular component, like an anchor button, we have like 30 of them. I created separate tests for, as you can see, for all of the browsers, and I'm sure that this is working. Like I executed basically even on Mac because our framework is cross-platform, and I had to check it there, and it's working. I don't know whether, to be honest, whether this is, if you execute it through Appium for in mobile web browsers, I'm not sure that there is the same, but at least for desktop web browsers, it's working, I think.
Perfect.
Yeah.
The only other question we have so far before we dive back into it is, 1 second, they asked. Any tips for handling dynamic changing locators as in an Angular application?
As in what application? I didn't hear.
An Angular application.
It really depends what do you understand by dynamic locator. Usually, I will show you another article that I wrote a while ago. It was, I'm a really keen fan on for expats. I even created this article for Java 2 a while ago. Here it is, expats, and I really like expats, because there are all these different cool methods inside this expat, and there is this really I don't know whether you heard of this expat access. It's this really complex, like syntax where basically you can traverse the DOM, but usually when I need to write really complex locators, I usually use XPath and use just the stable part of the locator. For example, if you have tables or names or whatever, one way to do it is just to get to use contains or end suites, start suites, and this is how we get the proper locator. And sometimes we can build this XPath or CSS dynamically. Another way, if this doesn't help, is just to I did that like years ago in one of the companies I worked for. We didn't have on the shopping cart like stable locators. I asked our developers to put IDs or something. They didn't do it. Then I just asked my manager to give me permissions to the source control, and I just went to the HTML and I put locators there, in order to
Nice.
handle that. Yeah.
Anton, another question from they want to know, for the navigation, you're using an open method in the page object. How do you deal with different environments, for example? Why not create a navigation class to handle all this logic?
Okay, I will show you directly. Let me check. There is another, even I think the 9th or the 10th chapter in the book is about that. I'm not sure. Let me check the demos. I think I have an example for that. Test data preparation. I think here maybe I show that. For this kind of stuff, like hard coding the data and handling URLs, etc., I usually use JSON files for the different environments. And before the JSON was introduced, here it is. Basically, for each environment, I will have different configuration. For example, for local runs, I will use debug. Then if I want to run my tests in continuous integration in the QA environment, then I will use release. If there is one more, I will just create one more, configuration here. And the way this works is that basically I created a few here in the configuration. For each section here of the, basically from this JSON, I have a C# representation of it. Here it is, URL settings. I have shop URL and account URL. Then I have this URL determiner class that it's basically returning, it's combining the shop URL from the settings. I have this instance. The thing that it's doing is that basically we are using the technology of Microsoft for reading the this configuration service to read the sections, and then through this get method, it's basically automatically converting the JSON to a C# class. Yes. And filling this C# object, and then I can use it directly. And basically these files, if I double click on my project, this is MS Build. This is the build technology of Microsoft. Right here, as you can see, I need this one here. I have this special variable called configuration. When I build my project, I will get this value here. It's the same like if I open the file folder, I can build the project from command line like this. If I open the command line, I can write .NET build equal configuration equal to, for example, release. This is how I can build it from the console. And basically this is the same like we do in continuous integration. And the magic here is that basically the build engine of Microsoft for the .NET will prefill this and change this variable configuration with the one here, debug, release, etc. And basically this one will just, as you see, this one here, copy to output directory. This is part of MS Build. This will instruct the build engine to copy the right file with this particular extension. This means that if I want to have a different URL for debug, here I will have local Beotric solution. This is my local environment. I can change here all of the different, for example, timeouts, as you asked me before for the explicit wait. Then I will have another URL here and another timeouts for my demo Beotric solution, and I can have as many as I like. And again, I'm using this directly C#. I can read these XMLs, which is really great. No more hard-coded data. I have only one set of tests, and they're all changed when I build the project in the right configuration. That's it.
Cool. So Anton, I just want to be clear. When you say page objects, this applies to all languages. It just so happens you're using C# as an example. Methods may be different, or approaches might be different in other languages, but the concept is still the same. Do you agree with that?
Yeah, of course. Absolutely.
Yeah. So
the only difference in the only difference in C# is that I showed you this version with the 3 files, the partial classes, but basically you can do the same thing in any language, just in a single file. That's absolutely fine. I mean, even the decorator and all of the patterns that I choose to show you, they are all applicable for Java and for most of the object-oriented languages. Cool. It's completely fine. I mean, this is why I used a few words from other languages. Like, I'm not using always the word property, but I'm using the Java version, like the getter.
Right. Nice.
Yeah.
So someone in YouTube asked, are there any design patterns you can use to help manage running big test suites of over 5,000 test scripts? Don't know if any page object, not any like any design patterns that you can use that make your tests more robust as you run larger test suites, or running in parallel or anything like that.
To run them in parallel. Well, you know, everything is connected for me. In order to first, not everything is connected to the framework itself. Sometimes it's how you write the tests. Even if you use, for example, some people that you use our framework that it's built really to be highly maintainable, reliable, etc. If you write the tests in a coupled way, in not a fashion where the test can be run in parallel. Just let me give you an example. For example, in one of the projects that we worked right now for a client, their application is not built in a way where we can basically run the test in parallel. Why? Because there, for all of the users in their system, part of one account, they use global settings, meaning that if I want to, for example, for user 1 to have one set of settings and for user 2 to have other settings, basically I cannot do that. And all of these users, they share almost the same data. And if I run the test in parallel, then basically I will just mess, everything will crash. And this is why their system is not built in a way that it's really, be able to run the test in parallel. In other cases, this was the case, for example, when I worked for Telerik as QA architect. It's up to the design, how you design your test. For example, it's this is why, by the way, I named this 10th chapter test data preparation, because I think this is really, really important for basically for the test to be able to run in parallel. You use some API or access to the database to set up the data. And I believe that in order to be able to run large test suites like with thousands of tests, you need to be able to create separate test data for each test and then delete it from the dedicated environment. Because I saw many teams that they just use this shared data or a single user for all of the tests, and then they check it. Then, for example, if some of the tests leaves the user or the system in inconsistent way, then all of other tests will fail or will get not proper results. So I believe this is huge, like be able to execute, for example, SQL to or repositories, etc., to create the data. This is really huge, and usually maybe this is even harder than creating the framework itself.
Right.
But in most cases, usually developers are quite helpful if you ask them and if you explain what you want to do. You can even, maybe this is not the best practice, but you can reference the production code for some of the stuff and just create some of the data through the code. If you know that it's covered with unit and integration tests, it's much better than, for example, creating like data on Wife, and then when you restore the data to expect that it's there.
Right.
I saw that too.
Yep. So Anton, folks that don't know Beltrex, could you just tell a little bit more about what it is, when someone would use it? Does it have these patterns baked in already that saves people a lot of time for having to create them themselves?
Yeah, basically Beltrex, you can go to our website. Here it is, Beltrex Solutions. It's an open source test automation framework. Its history is that basically, like years ago, I started to work as a consultant, and many companies wanted for me to do the same thing over and over again to create this framework for them. And I just decided to create this open source solution so that the support is centralized. And basically, we ended up with this solution that you can test web, Android, iOS, desktop API. It's written in C#. We basically used, Selenium, Appium, WinAppDriver, REST#. It's cross-platform since we use .NET Core. And lately, even we added support for example, integration with different reporting portal. Like tools for visualizing test results, like Allure, Report Portal, also with test case management systems and such. And yeah, basically right now I started to create some series here on my website called, I think they are part of, let me check. Basically, I'm doing this series of blog posts about how you can create your own custom framework. So you can, basically I'm teaching the people how to do this themselves, but design it in the proper way. But again, it's completely free and open source, and it's a lot of effort. I built it for 3 years full time. It's more than 200,000 lines of code, more than 120 projects. It's a lot of code, and it's really well tested. It has more than, it's covered with more than 5,000 tests. It has a really nice documentation here. Here also you can, basically everything is documented. Really cool documentation, which is, and one more thing. Basically, you can do this for any kind of project. Even on a conference like 2 hours ago, I shared this. I like the documentations, and I really think that they're really important. But as you probably know, many of you that have to maintain a framework or something similar, when a new colleague join your team, I bet that you spend countless hours teaching them again and again the same things, how to use the framework or how to write proper tests. This is why I get with the idea about creating these getting started guides or starter kits about teaching people how to use the framework itself. Basically, this is a project where you have folders for each particular feature of the framework, and these are real tests that you can execute from the test, and you can execute them, run them, debug them, etc. But you have all of these comments here explaining how the different features work and why they work the way they do, explaining the patterns. And after each section, you can do this exercise here. to check whether you get the ideas, and you're going number by number, technology by technology. We have this for the web, for mobile, for desktop, for everything. And by the way, we do the same thing when we integrate the framework for clients. We do the same thing for them for the custom version of the framework that we create for them, and it's really cool. And it's really helpful to allow, for example, developers to learn how to use the framework itself and write tests.
Awesome. Yeah, so that's all the time we have. I just want people to know more about Beltrix, and also for folks to know that if they want to really dive in deep, they should definitely head on over to Amazon.com and pick up your book, Design Patterns for High Quality Automated Test, High Quality Test Attributes, and Best Practices. So, Anton, before we go, any parting words of wisdom you want to leave the guild?
Sorry?
Before we go, any parting words of wisdom that you want to leave the guild?
Just, keep learning and reading books. I think this is really important. And I think in order to succeed in our profession, you need to check and read a lot of blog posts,
Yep.
because not everything is in the books, because they get outdated quite fast. So read blog posts.
Absolutely. Awesome. Thanks so much, Anton, for your time. Really appreciate it and really love this this initiative you're taking here with Design Patterns. So thank you so much.
Thank you. Thank you for having me.
Anytime. Cheers.
Cheers. Bye.
All right, so as I mentioned, if you want to learn more, definitely head on over to Amazon. I'll have a link in the show notes. Let me bring this up really quick to show you when the stream is done. The recording will be available. And, oops, I shouldn't have done that. And hold on, let me get out of this view. I don't have it set up, but what you need to do is just go to testguild.com/podcast. And under podcasts, there'll be an option for meetups. Click on the meetups. In a few days, you'll see one for Anton, and he'll have his own section there with all the links to all his stuff and the video embedded there. Or if you subscribe to YouTube, you'll have access to the video once it's done as well. So I just want to thank you, everyone, for your time and for all your questions and for making this awesome. Really appreciate it. And check us out next week, same time, on another awesome meetup. And before we go, show some love. Click on support the meetup. If you're in the Guild conference section, click on that button. If you're in YouTube, click the link in the comment. This helps support the show. So you definitely want to check out ExcelQ, which has an AI-based technology that'll help you create tests. So if you have people that aren't programmers like Anton or hardcore automation engineers, this is a solution you might want to check out as well for a team that may be more QA-centric that might help you with your automation. So definitely check them out. All you need to do is click the link and just learn more about them and let me know what you think if you do check them out. So that's it for this episode of the Test Guild Meetup. Appreciate you all. See you here next week. Cheers.